This video is going to take a look at solving systems of equations using a method known as elimination. It's also known as the addition method in some textbooks. That's right. What if I told you there are actually 3 different ways to solve a system of equations? Graphing, substitution, and elimination. There's also a few other ways that are used in more advanced mathematics when you have more than 2 equations. But for our purposes, we'll look at these 3 methods. Today, elimination, also known as the addition method. The idea here is if we don't have a lone variable, the substitution method can become very difficult to solve because the fractions get ugly. However, we do know some things. We know we can add the same thing to both sides of an equation and we'll still get a true statement. We also know that an equal sign means both sides are the same thing. So we can add both sides of both equations together. Let me show you what that means. I have these 2 equations here. 2x minus 4y equals 6 and 3x plus 4y equals 14. We can add these equations together because what's on the left is the same as what's on the right. So we're really adding the same thing to both sides. And when we add 2x plus 3x, we get 5x's. When we add negative 4y plus 4y, that conveniently goes to 0. That's really important there. Negative 4y and positive 4y conveniently goes to 0. That's what we want to happen. Because then all that's left on the other side is 6 plus 14, which is 20. Now I just have to divide both sides by 5, and I know that x is equal to 4. Still need to find y. I can get y from either equation. It doesn't really matter. I'm going to pick the first because the numbers look smaller. 2x, we know x is 4, minus 4y equals 6. Well, 2 times 4 is 8, minus 4y equals 6. Subtract 8 from both sides of the equation. Negative 4y equals negative 2. Divide both sides by negative 4, and y is equal to this nice little fraction, 1/2. So we're able to find the solution to this equation, x comma y, is 4 comma 1/2. And the way we got that is we added the 2 equations together because we had negative 4y and positive 4y that would subtract out to 0. That is going to be our goal today, that we add equations so that one variable subtracts out to 0, which means it only works with opposites. If we don't have opposites on either x or y, we're going to have to do a bit of work to get there by multiplying one or both equations by a constant to get the opposites that we want. Here's what I mean. Right now, if I added these equations together, we don't have opposites in front of x, and we don't have opposites in front of y's. A variable would not disappear. However, if I look at the x's, I notice that negative 2x can be multiplied by something to become the opposite of 4, to become negative 4. If I multiply this first equation by 2, 2 times negative 2 would be negative 4. Then we would have opposites in front of the x's. Of course, if I do it to one side, I have to do the exact same thing to the other side. So multiplying by 2 gives me, let me get rid of these underlines here. It'll be 2 times negative 2 is negative 4x. Those are the opposites I want. And 2 times 3y will give me 6y equals 9 times 2 is 18. Now I have a new second equation, but it's got the opposites I want, so that 4x minus 4x will be 0. Negative 2y plus 6y is 4y. Negative 2 and 18 is 16. And we can solve this quite nicely by dividing by 4 to find out y is equal to 4. Still need to find x, so we'll go back to one of the original equations. I'm going to pick the second equation this time because those numbers look smaller. Just picking one, though. Both work. 4x minus 2y. We now know that y is 4 equals negative 2. And we can simplify a bit by multiplying. So we have 4x minus 8 equals negative 2. And now we'll solve by adding 8 to both sides. 4x equals 6. Divide by 4, and x is equal to, if I reduce that fraction, 3/2. And so x comma y, 3/2 comma 4 is the solution to the system of equations. We got that solution by multiplying the first equation by 2 because that would create the opposites we wanted in front of one of the variables, in this case, in front of the x's. Let's do some more examples. In this problem, which letter would be the easiest to get opposites in front of? If I look at the y's, we've got a negative 3y. We can make the first equation have a positive 3y by multiplying both sides by negative 3. Notice when we do that, we have negative 3 times 3x is negative 9x. Negative 3 times negative y is positive 3y. Negative 3 times 2 is negative 6. And this time I ended up with opposites in front of the y's. It doesn't matter which one we get opposites in front of. We just want to make sure they subtract out to 0. 2x minus 9y is negative 7x. Negative 8 and negative 6 is negative 14. Dividing both sides by negative 7, x is equal to a positive 2. Now we have to go back to one of the original equations. This time I'm going to go to the first equation. 3x, 3 times 2 minus y equals 2. Notice I go back to the original equation that the problem gave me. 3 times 2 is 6 minus y equals 2. Subtract 6 from both sides. And negative y equals negative 4. Well, because that's negative 1y, we'll divide by negative 1. And y then equals a positive 4. So x comma y, the solution here is 2 comma 4. By getting opposites in front of the y by multiplying that first equation by negative 3, we were able to eliminate the y's and just find the x and then go back and get the y at the end. One last example here. This one's a little bit more involved because you'll notice we can't easily get opposites in front of x. We can't easily get opposites in front of y's by multiplying one equation by something to become the opposite of the other. What we're going to have to do here is force it by multiplying both equations by something. 3 times 5 is 15 on the x's. 3 times 4 is 12 on the y's. 12 is smaller than 15, so I'm going to go with the smaller number. It works either way. But we're going to try and get positive 12 and negative 12 in front of the y's. So the first equation I'm going to multiply by 4. That's going to give me negative 20x minus 12y equals 4 times 3 is 12. And because I have negative 12 here, we want positive 12 from the second equation. To get a positive 12, we're going to have to multiply by negative 3. So negative 3 times 3x is negative 9x. Negative 3 times negative 4y is positive 12y. Those are the opposites we want. And negative 3 times negative 25 is positive 75. The numbers are getting big, but that's okay because what we wanted was opposites, and that's what we got. Opposites in front of the y's are going to subtract out to 0. So negative 20 and negative 9 is negative 29x. 75 and 12 is 87. And the good news is when we divide both sides by negative 29, you might need a calculator, but it's a nice, pretty negative 3. We have our x. Get the y from any one of the other equations. I'm going to use the one with the smaller numbers just because I hope that'll be nicer. Negative 5x, which is negative 3, minus 3y equals 3. Well, negative 5 times negative 3 is positive 15. Minus 3y equals 3. Solve by subtracting 15 from both sides. Negative 3y equals negative 12. Divide by negative 3. And y is a positive 4. So these two equations are going to cross at negative 3, comma 4. That is the elimination method, also known as the addition method. We multiply to get opposites in front of one of the variables, either the x or the y. And once we have opposites, they will easily subtract out, giving us a quick answer to one of the variables. That's how we solve systems by elimination. Take a look at it on your homework assignment. I hope you found this video helpful, and ask your instructor if you have any questions as you work through it. Good luck.